we are now starting chapter 6, and this is really the beginning of the second half of the MAT 217 analysis for business class. The first half was all about optimization and maximization, minimization, and things related to that. This next half of the class is all about probability and statistics, and we're going to focus on probability for quite a bit of it. So before we can get to probability, we have to ask you the question of, do you know how to count? And you might think you do, but you might be in for a surprise that you might need a little refresher on counting, silly as that sounds. So I'm just going to say probably not and put a little happy face there. Okay, so keep in mind, what we're going to be working on in chapter 6 is just counting. We're not working on probability yet. We're just counting things. So, for example, how many ways are there to make an outfit if you have 5 shirts, 3 pairs of pants, and 2 colors of socks, 2 different types of socks? Or how many ways are there to make a deck, or you make a 5 card hand out of a standard deck of playing cards? Things like that. It's going to be counting very strange things. So, before we can get there, though, we need to talk about a little bit of vocabulary. So let's run through this, and please feel free to ask me if you have any questions on any of these things. So now, a set. A set is simple. It's just a collection of, and fill in the blank. You can make it. I always use the word things when I teach this in class, but it can be anything. It could be numbers, which is something we're used to. For example, the set of whole numbers. Do you remember what those are? And our notation here. So I'll say the set of whole numbers, we'll abbreviate that as a W, and we're going to say that is equal to, oops, and that is supposed to be a bracket. Let's try that again. Now, what do the whole numbers look like? 0, 1, 2, 3, and so on. So the set of whole numbers is all of your counting numbers, including 0, right? That's a set. But it could also be, for example, I don't know, the Arizona Diamondbacks would be a set, especially if you wanted to talk about it like as in I have a deck of cards of like baseball trading cards, and I have all of the Diamondbacks, right? That'd be a set. Now, a subset would be a portion of the set that, but not well, we'll be careful when I say but not, because we have something called a proper subset and a set. But anything that's restricted to a portion of that group. So, for example, if we were talking about the Diamondbacks, the baseball team, maybe a subset of them would be the pitchers. For those of you who don't know baseball, we can do makeup, right? So you have all the different kinds of MAC makeup. And a subset of that might be the different eyeshadows. I don't know, something like that. So the idea is it's just a smaller grouping. So now, how would we do that? Let's just stick with the Diamondbacks and pitchers because I have nice little letters for that. The Diamondbacks and the pitchers. So what I would want to say is maybe the pitchers are a subset of the Diamondbacks. So I use D to represent the set of Diamondbacks and P to represent the pitchers. Now, what we're going to do is we're going to say we're going to have this kind of notation. It's not a C. It's kind of like an elongated symbol, but if you just kind of write a C, you'll be close enough. And you'll notice it in WebAssign, you'll get an example of that, or whatever online system you're using, it'll be typed in there, so you'll kind of see what I'm talking about. But now, there is the difference between a subset and a proper subset. Now, what the difference is, a subset just means literally anything. It's as long as it's made up, the subset is made up of the elements. Ha ha ha. There's another vocabulary word in there for you. What is an element? Well, just like a matrix, it's a piece of the set, right? It's something from the set. So therefore, if a subset is made up of elements of the full set. So for example, the pitchers are made up of Diamondbacks, right? All the pitchers on the Diamondbacks are Diamondbacks, so therefore they are a subset. Okay, now what is a proper subset? Well, the idea in a proper subset is saying it can't be everybody, because then it's not a subset anymore. Now it's just a set. So, for example, the Diamondbacks, I'm going to do a new little example here. Let's talk about M represents all of the males on the team. F represents all of the females on the team. Okay? Would the males be a proper subset of the Diamondbacks? Well, proper subset would mean they have to be less. It can't be everybody. And unfortunately, as of right now in baseball, there are no women playing Major League Baseball. There are no women on the Diamondbacks team. So therefore, what does that mean? They are not a proper subset, but they are a regular subset. So that's kind of the difference here. Now, which notation means which? Well, if you think about these symbols as less than or equal to, and this one over here just being less than, you can kind of figure it out. A proper subset is not allowed to be equal to. So therefore, this one right here is your proper subset notation. And this one right here kind of resembles the less than or equal to, because the equal to part there. And so therefore this would just be a subset. So it means it can be not the entire group of people, like the pitchers are not the entire team, but if they were, that would be okay. It's still a subset, just not a proper subset. All right. Now, after this section, the whole proper subset and subset thing goes away, and they're all subsets. Move on. Okay. But if you see that notation or you see that comments come up anywhere, I wanted you to understand what you were seeing and the delineation between this two. Now, my favorite kind of set, this kind of confuses people sometimes. It's called the empty set. What is the empty set? Well, it just means there are no elements in the set. So meaning, for example, females, from the previous example over here where we're talking about, it's going to jump on us, where we're talking about females on the Diamondbacks, right? Is that a subset of the team of the Diamondbacks? Because we said there's nobody there, right? There are no females. So therefore, is there a subset? And the answer is yes. Yes, they are. Because it's possible. If at some point in time a girl makes her way up from the minors into the majors, it's possible she could be a Diamondback. So therefore, this is a true statement. This is okay. Now, how would we write that in set notation with our little brackets? Well, we would simply just do that. You would show your brackets, and what goes in there? Nothing. Empty set. And then there's also another way of writing it with a 0 with a slash through it. It's referred to as the null set. That is N-U-L-L, null set. And that's another way of notating empty set. So you can either do this or this. Just be familiar with both, just in case the test or a book or whatever you see uses those different notations. They both mean the same thing. The set has no elements in it. Because for this example, because there are no female Diamondbacks. So therefore, it is an empty set. Okay, a little bit more, and then we're almost done with this stuff. Okay, a finite versus infinite. Okay, well, you kind of should know infinite from previous math classes. Infinite, it just means it goes on forever and ever and ever and ever and ever. It's not countable. The key idea here is we're going to say it's not countable. There is just so many elements you couldn't count them. Even if you took in your entire lifetime and you were just kept counting, you would never be able to count it because there would just be more because it's infinite. Where the concept of finite means it is countable. It could be huge. It could be in the billions or trillions or Googleplex. It could be whatever you want it to be, but it is still countable. There is a specific number of elements that we're going to be counting, or dogs, or eyeshadows, or whatever it is. It's a finite number. Okay, so just when you hear those words, it's just important you understand what those mean, what they're trying to give you information. Now, a union is a operator in set notation. Okay, and what it's saying is very, very simple. All it's saying is if I had a set A, and let's say it had the numbers in it 1, 2, and 3. Whoops, that's supposed to be a bracket. And then I had the set B, and it had the numbers 2, 3, and 4 in it. And if I said A union B, what does that mean? Well, think of union as union can be thought as getting married, right? If you are getting married, you are having a union. And so a union means all of your stuff goes together. Everybody, all right, we know in reality that's not true. All of my stuff went to the curb and we kept all my wife's stuff. It was nicer. But but that aside, theoretically, everybody keeps their stuff, and you wouldn't necessarily keep duplicates. So you would look at both of the sets and say, do I have a number one? Yes, yes. One of mine has a number one. Do I have another two? Yes, we actually have two of them, but it doesn't matter. We'll write one of them in our union set. And again, same thing for threes. And then last but not least, we have a four. So therefore, the union is made up of all of the elements from both of the other sets put together. That's the idea of union. Your stuff comes together. Intersection then is the divorce. No, I'm just kidding. That's not really what it is. Oh, and notice the symbol here. That is, again, it's not a U. It's just like the other one was in a C. It's kind of elongated. It's a Greek symbol, but that's okay. Just you'll if you write a U, you're fine. Just don't make it a U. That's not okay. There shouldn't be a stem there. Okay. Um, so intersection, intersection, intersection. It's another operator. Okay, and same. We'll use the same A and B. Okay, what it's saying is A intersect B. It's the same as the union symbol, but upside down. And think of it like streets, right? If someone said you were on Union Hills and 32nd Street, let's say, okay? What if you were at the intersection? What does that mean? Well, it means you're on both things. You're on 32nd Street and Union Hills. If someone called you and said, you said, where are you? And said, I'm at the intersection of Union Hills and 32nd Street. So they would say to you, are you on Union Hills? You say, yes. Are you on 32nd Street? Yes, I'm on both because I'm at the intersection. So same idea here. What do these both have in common? That would be an intersection. So therefore, in this set, they both have a 2 and they both have a 3. The 1 and the 4 are unique to one set or the other, so therefore they're not at the intersection. And that's all. That's all intersections are. So unfortunately, not divorces, but that's the big idea. All right. And I will urge you to try not to memorize or try not to use any tricks to remember unions and intersections, especially when it comes to word problem. Like, don't try to say intersections are ors and unions are ands. That is very dangerous, very, very dangerous. Because in the English language, the word and or can take on different meanings, and sometimes a union is an and sometimes a union is an or vice versa with intersections. So just try not to memorize it. Try to understand what they're saying. When we talk about an intersection, we're talking about things they have in common. When we're talking about a union, we're talking about taking elements from both sets and putting them together. Okay? Almost there, guys. Hang in there. Just a few more definitions. Complement, complement, complement. Complement is just a really simple concept. It's the concept of not. So for example, if I had a set where this represented the even numbers. Okay. So therefore, the complement notation looks like a little apostrophe. It's like a little prime, right? So what does this mean? Careful, it doesn't mean odd. No, no, no. It just means not even. All right. So therefore, if even the set of even numbers was 2, 4, and you could include the negatives if you wanted to, negative 2, and excuse me, hold on, dot, 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 negative 4, negative 2. Is 0 an even number? Depends on the textbook. I'm going to argue no. So I'm going to skip over that. We'll go 2, 4, 6, and so on. So therefore, what would be included in the not evens? What would be in the make that look a little better. There we go. In the E complement, well, that would be everything else. So this would be negative 5, negative 3, negative 1, 0, 1, 3, 5, and so on. So just be careful. Sometimes you can play this game where you can say, it's yes, it is or it isn't. So for example, if we were like flipping a coin, which we'll do a lot of, okay, in the later on, flipping a coin, you can say you could get two outcomes. You either could get heads or tails. So at some point in time, we might say, like, we have the complement of tails. Well, there's only one other option. That makes heads. So you can do that if you know for sure there are only two options. Um, just be careful and not to make any oversimplifications, because you can get yourself into trouble. All right, we're almost here. We're almost here. We got three more vocabulary words. Universal set. Universal set. This just means the set that contains every possible element. Okay, so um, if I were, and it's typically abbreviated in this chapter, they're using the letter S. So the universal set, when they, if I, in previous sets, I've been giving them a letter, calling it A or calling it B, whatever. They're using the letter S. So they're saying the universal set is equal to S. So if you see them saying S, know that they're saying this isn't a subset. This is the full set. It contains every element. So if we were talking about the universal set of baseball cards, back to the baseball thing, baseball cards. Um, and we can be a little more specific than that. Let's say it's the 2017 baseball cards. Well, what does that mean if we're talking about the universal set? It means every 2017 baseball card. Or hey, if you're a makeup person, it's every 2017 shade of MAC makeup that they made this year. Or if you're into socks, it's every, I don't know, whatever you like, but it's just every possible element, every possible option. So there you go. Okay. So universal set. If they say it's the universal set, they're just giving information. They're saying it contains everything. Distinguishable versus indistinguishable. Okay, this is going to be important later. This vocabulary word pops up a lot. The idea is, let's say we're rolling dice, okay, and we're gonna play a little game. We're gonna roll some dice. We're gonna figure out probabilities. Well, and one of the die is red, and one of the die is blue. These are distinguishable because you can tell the difference between them, right? If I roll a number like a 1 on the red die and I roll a 2 on the blue die, you can tell me which die is which, right? Well, indistinguishable dice would be, well, what if your dice are the same color? And after you roll them, would you really know which die rolled the 1 and which die rolled the 2 since they look exactly the same? That's the idea of distinguishable versus indistinguishable. And it will become the bane of all of our existence a little bit later on. It's fun. Okay. So that's when they talk about distinguishable, it just means you can tell the difference. Indistinguishable means you can't. They look identical. There's no way to tell them apart. Last but not least, cardinality. This is just the fancy math word of asking you how many elements are in the set or subset. It doesn't matter, just any kind of set. So for example, if I gave you a set, let's just make something up, B equals the set of, I don't know, the color red, blue, and green. Okay, so that is our set. How I would write this, you ready? This makes total sense. How I write cardinality is the letter N. Yeah, I know. Well, you can think of it as the number. What is the number of elements of B? Well, there were three elements in there because I had red, blue, and green, so there are three elements. So that's all. It's just asking you how many unique elements are there in the set. There are three of them. All right, that is it for the vocabulary portion. Then now we're just going to practice a little bit, and you're moving on. And this is, by the way, this is a couple sections. If you're in the web assigned book, this is 6.1 and 6.2. If you're in the other books, well, then match your sections accordingly. Okay, best of luck.